Today I will be presenting about advanced manufacturing for dental prosthetics. As of 2019, the global dental market is roughly 33 billion US dollars, with tooth replacement and repair via dental crowns being one of the most common procedures. However, conventional manufacturing methods are rather archaic. They involve a tedious four-step process: impression creation, cast molding, mold fabrication, and crown molding. This entire process is extremely time-consuming, taking upwards to several weeks. It is also rather expensive, which reduces the availability of these treatments to the public. It also requires surface finishing, which can be rather inaccurate because it is done manually by hand. This can result in a poor fit and cause discomfort for the patient. With the advent of 3D printing, rapid prototyping and manufacturing became possible. In the biomedical industry, 3D printing is already being used to fabricate custom prosthetic limbs and blood vessels. However, this technology is still rather scarce in the dental industry. Therefore, we are proposing to use stereolithography or SLA 3D printing for the manufacturing of dental crowns. This can make manufacturing these crowns much faster, cheaper, and more accurate. Current dental crown manufacturing techniques are slow, expensive, and inaccurate. By implementing SLA 3D printing, the manufacturing process can be greatly simplified and even be done computer-side, and also reduce the cost to create a crown. The improved accuracy due to 3D scanning and CAD technology will also provide patients with better comfort with their crowns. The type of SLA we are proposing is bottom-up SLA. This technique has the build platform move up by a distance of a layer thickness each time as it is sat inside the tank of liquid polymer. A UV laser is used to cure the resin, and the object is created layer by layer. The main reason for using bottom-up as opposed to top-down SLA is due to the lower material cost of bottom-up and for it being more suitable to be placed at computer side. The complete design process of a bottom-up SLA printed crown is highlighted below. First is the examination. The dentist will examine the tooth and remove any decayed tooth tissue. Next is 3D impression, where a silicone impression of the mouth is used to produce casts which are used to prepare the initial model. Next is 3D scanning, where the initial model is scanned by an optical 3D scanner, which examines the model from different perspectives and creates an accurate 3D representation with a resolution of at least 0.01 millimeters. Following that is CAD software processing, where the scanning is converted into a 3D model by CAD software. Next is the creation of a digital framework and strategy. The digital design framework is produced based on the captured geometry of the tooth. The design strategy can be implemented by design tools in the CAD software and combined by large data sets of the complex shape to generate one geometric model. Next is design restoration, where the CAD software will transform the model into a set of commands which drives the SLA printer to fabricate the dental crown. Next is the actual printing, where the computer will generate build paths layer by layer, and the SLA printer will cure the material along the path from bottom to top until the entire dental crown is fabricated. Next, the dental crown will require some post-processing under UV light and high temperature to gain high thermal and mechanical properties before it is ready for installation. In the figure on the left, you can see a flowchart highlighting the steps involved in creating a dental crown using this SLA method. In the middle, you can see an example of an SLA crown, and it can be observed of the high surface quality of the finished product. And on the right, you can see a diagram highlighting how well an SLA printed crown actually fits, with the green parts of the tooth highlighting a good fit, the red being a positive error and blue being a negative error. It can be seen that the majority of the crown is actually green, meaning it is a really good fit in the patient's mouth. So our design criteria for this involves novelties of the SLA method include incorporating CAD software to replace manual work, less training time for manipulating the machine, and no harmful dust or fumes are created to harm the working environment. When compared to the conventional method, it can be seen that SLA greatly reduces the build time from multiple days and upwards to several weeks down to just a few hours. You can also see a notable increase in accuracy, going from 75 micrometers to 49 micrometers. However, SLA printing is not without its issues. SLA printed parts, when exposed to sunlight for a long duration of time, will harm both its aesthetics and its mechanical strength. The post-processing is also required to obtain strong thermal and mechanical properties. A polymerization time of 1 to 2 hours in a UV light box or in higher temperatures will significantly increase the feasibility of resin materials for dental applications. However, the overall feasibility of the SLA method is high, as it solves many of the conventional method's issues. However, it is still not widely applied due to these limitations. Further research is required to determine the optimal material and process and the optimal post-processing time to increase the durability of the crown. So SLA printing utilizes ceramic polymer resins as raw material compounded with ceramic powders and photo initiator mixed into a liquid bed of monomers. Here's a comparison of 3 types of dental ceramics. The ceramic that we are suggesting used is zirconium dioxide, as it shows the best material properties from flexural strength, fractural toughness, Young's modulus, and micro hardness. The material strength of dental polymers is rather comparable to actual human teeth. The average maximum stress of human teeth is around 62 megapascals, and for dental ceramics it is approximately 55 megapascals. The cost of fabricating a dental crown from using the conventional method can cost patients from $500 to over $2,000. However, by utilizing ceramic polymer resin, the material cost can be reduced to around $58 per liter. This will also result in less cost for the patient, increasing the availability of this kind of treatment to the public. The time to create a crown is also greatly reduced. Using the conventional methods, it can take up to 2 weeks and multiple visits to the dentist to create the crown. However, by using SLA, it can be shortened to less than an hour. It can even be done computer-side, meaning the crown can be created and installed on the same day in just 1 visit to the dentist. Other benefits of SLA printing include higher accuracy of the crown or implant. By scanning the tooth or part of the tooth, a very accurate model can be created. SLA technology also guarantees high survival rate of 99.1% as compared to the 95% of conventional dental crowns. In conclusion, SLA can be used to reduce the build time from upwards to a few weeks down to just a few hours. It can also reduce the fabrication cost since it does not require the creation of custom molds for every patient. The final product will also be extremely accurate, as it does not require much manual finishing. This will increase the comfort for the patient as well. Overall, SLA is thought to be a suitable replacement for the current manufacturing process of dental prosthetics. In the future, 3D printing of ceramics will be further developed. This will greatly reduce the cost of ceramic 3D printers and make them more available. Companies such as Formlabs is already making great strides in this field, and we believe that 3D printing dental prosthetics will become the mainstream way of manufacturing dental crowns and implants.